Today we're going to start looking at what is a quadratic and what makes it different from a linear equation, since we have been studying linear equations all year. A linear equation, just as a reminder, of course, is a line. We have a parent function of a linear equation. Think of slope-intercept form. And our parent function is just y equals x. If we were to graph that, it's going to be a line. We can also tell it's linear because x is to the first power right here. Well, today we're going to start graphing quadratics. And what makes something a quadratic and what does it look like? Well, it's going to be a U shape when we graph it in just a moment, and we call that U shape a parabola. Now, we also have a parent function for the quadratic, and it looks like y equals x squared. And I just think of parent functions as it's the easiest function of that type. So y equals x squared is the easiest quadratic. Now, how do we know it's quadratic? One is because x is to the second power. So if that is your highest exponent, it is going to be a quadratic equation. So let's do some graphing real quickly. And we're going to graph y equals x squared. Now, the first way we learned how to graph is, of course, the table of values. And you can also use your graphing calculator, but I like you to know how to do a little bit by hand. So let's say, what if x is 0? What is y going to be? Well, let's go over here. I know this is easy, but we're really plugging in x is 0. So when x is 0, 0 squared is going to be 0. So we would have a point at 0, 0. All right, what about if x is 1? Well, 1 squared is going to be 1. Well, what if x is a negative 1? What is negative 1 times negative 1? That's positive 1. Okay, we're going to do a few more. I know with lines we did 3 points. With parabolas we're going to do at least 5. So let's say, what if x is 2? Well, if x is 2, 2 times 2 is going to be 4. And then I'd also look at the negative value. Negative 2. If x is negative 2, negative 2 times negative 2 is going to be a positive 4. All right, I'm going to graph these points. So I already have my 0, 0. And then I'm going to put a point at 1, 1, a point at negative 1, 1. Then I've got 2, 4. And then I have negative 2, 4. So notice I have my 5 points. I would always want you to use 5 points at least when you're doing a quadratic. Now you're going to just make a smooth kind of U shape, and then you're gonna barely go over those highest points, because a parabola many times will kind of shoot up pretty quickly. So I like your graph to be exact. So just don't go too much past those last points. Now notice we are going to refer to this graph or parabola as opening up when it opens up and it keeps going up, it's going to have a minimum point. So we're going to call this a minimum. Now, as a review, we have studied what does it mean to be the domain of this function. Well, what are all the x values? Domain is just a fancy word for x. Well, if you look at the parabola, it goes left and right forever. And so we refer to that as all real numbers. And that's just an abbreviation for all real numbers. Now the range means all the y values. So ask yourself, how would I describe all the y values? Well, you do have a minimum y value. And notice what your smallest y value is. That is 0. And so if you had to put a number to this minimum, it's referring to the y value. Because in a parabola that opens up or down, the domain will always be all real numbers because your graph is going to go left and right forever. So when it's talking about minimum, you're looking at that y value. So what is the range? It's everything greater than or equal to 0. So if we were using set notation, we could say y such that y is greater than or equal to 0. I'm going to stop there and I'll do another video to follow up.